might be good. So anyway, let's get started. So nice to meet you all. I can't, by the way, see how many of you are in here. That's probably for the best. But yeah, I'm here to talk about Git today, how we use it in a professional environment. I will use my current project as an example, and shortly about how your GitHub profile should look like when you're applying for jobs or internships or whatever. But first, shortly about me. I'm Jere Luomäki. I graduated from OAMK in 2018. I've been doing web development ever since, at first with Java and various JavaScript frameworks like older React and some Angular and Vue as well, and all the other things as well. For now, for about 2 years, I've been doing mostly Clojure, which Jukka actually will tell you about more tomorrow, I think. Maybe, yes, I hope. But at my current project at Solita, I've been doing full stack Clojure for 1 year now, a bit over 1 year, with Clojure on the back end and Clojure script on the front end. When I'm not working, I can usually be found from Kamppalu Club doing Brazilian Jiu-Jitsu or lifting weights, or most likely from my home playing video games or Dungeons and Dragons. So as I said, if you have any questions about the presentation or anything else really, there should be some time for that at the end. But if there's some questions that you want to ask at the moment, go ahead. I cannot see the chat, so if there's some questions in the chat, if Kari or Lasse can ask me out loud, it would be great if it's something that we want to ask right away. But otherwise, just let's see at the end of the presentation. I should see the chat then as well. What was on the agenda? Oh my God, what's the transition? Yeah, so at first, a quick mention about Solita overall. I think you've seen, there was a larger presentations before, but still some refreshment on that part as well. Then Git in a nutshell, just some refreshment if you don't know much about it. I think you know the basics at least already, but refreshment never hurts. Then a small part about how we use Git in our project and professional environment in general. And then lastly, how and why to prepare your GitHub page for job applications, making a sort of a Git portfolio for yourself. But yeah, that should be the agenda. Of course, questions and comments at the end if we have time. We should have. But yeah, shortly about Solita. It's a primarily a software consultancy company. Kari can interrupt me if I'm saying something that's really wrong, but yeah, we do software development for customers. Public sector is a big part. We also do some business stuff, which I don't know too much about, but the more familiar parts are the data stuff, then service and development, and of course, continuous services design and development. Data stuff is really big, increasing all the time. Then the service and software development is the part that I'm doing, and probably the part that you all are most interested in. And then there's primarily some cloud upkeep and so on at the continuous services design and development part. But I won't go too deep onto those things. Solid has grown all across Northern Europe. Started from Tampere, Finland. We have multiple offices all around and some remote offices as well, some smaller ones, since everybody is working from home anyway these days. And then some offices in Sweden, Estonia, Denmark, Germany, and Belgium. Some cooperations between countries, not too much, but at least some. I think there are some joint projects with the Tallinn office, if I'm not remembering incorrectly, not 100% sure, but some cooperations between countries at least. If nothing else, then over Slack at least, sharing some memes, if nothing else. In Oulu, which is probably the office that you're most interested in, we have currently 82 people from all units like dev data, cloud connectivity, and design, working as project teams. Usually a project team has some people from all the units, not always, but usually. Almost always some project teams working customer cases, mostly on our premises or home offices these days, of course. I'm not sure if the 82 is accurate, but at least it's probably not less than that, at least. It might have changed since these slides have been made. I'm not sure, but around that amount. The office is in the city center at Valke. You might have seen it in Kesäkatu. There's the door with the logo on it. Really nice location for an office. Yeah, I think that's all that I have about Solita. Of course, if you want to ask away, but if not, then let's move on to the actual matter at hand, which is Git version control system. So before we start talking about how to use it and how to prepare GitHub and whatever, let's just quickly refresh on what Git is in the first place. Of course, it's a free and open source and a distributed version control system. It's actually designed by some Finnish-Swedish dude called Linus Torvalds. You might have heard about him, the dude that made Linux. Distributed meaning everybody has backups. So when you pull or clone a project from Git, you get everything, and when there are multiple people working on a project, then everybody has backups. It's not the best way to explain what distributed version control system is, but well, that's what happens when everybody has everything. It's really handy when something goes wrong. One of big point is that it's really versatile, meaning you don't have to do things in a certain way. You can do. There's like Git supports multiple ways of working. Of course, one of which I'll introduce later on and tell about more. But the one that I talk about is not the only one, and not for everybody, it's not even the best way to do things, but it's the best way to do things for us and for most people, in my opinion. Security is handled by Git pretty well. There's basically every file, every commit has an SHA1 checksum, meaning when you do anything over Git, it leaves a trace, meaning you can't really do any shady stuff with Git. Well, you can, there's always room for human error, but Git itself is pretty secure. Then the thing that separates Git from other version control systems the most is the branching model. which I think is also the most important part of in any version control systems. I have a separate slide about that. Just so that things aren't only positive, the bit of a downside of Git is, of course, there's a slight learning curve. There's lots of commands that you have to learn and different states that you have to understand. And if you don't understand everything, or if you're unsure about something, there's a chance that you might get Git into such a state that you actually might lose your changes or do something else a bit hazard. But all in all, it's the most widely used version control system there is. Chances are that it's the only version control system that you will use in coming years. It's the only one that I've used so far. There are others, but Git is the most widely used nowadays, at least. And yeah. Next up, there's the branching model, which I mentioned already. Basically, how it works is when you make any changes to the code that you have on Git, you can push all the changes to one or multiple branches, which of course then leads to the situation where branches might have and will have separate contents, which is kind of the point of the whole branching model. Different branches can be merged together one way or another from the main or master branch to smaller development branches, or then back from the development branch to the master branch. And of course, and then branches are based on another branch, meaning when you create a branch, there's always a base where you get all the changes from. For example, in this small picture on the slide, there's the topic branches, which are based on the develop branch, and then the develop branch is based on the master one. So when the branch is created, at least then all the changes that are in all the stuff that is in the master branch is also in the develop branch and the topic branch. They don't update automatically. You have to get the changes yourself, but yeah. I think that's all that I have about branches. It's not the most easy thing to explain or the most simplest thing there is, but I hope that you will have some idea of the branching model, at least at the end of the presentation. If not, then feel free to ask, of course. And yeah, one term that I will be using is a repository, that is used all the time, but it's not the, yeah. So what is a repository? Basically, what a repository is a collection of various files, but also the history and all versions of those set files. So when you get a Git repository, you don't only get the current files or the current most up-to-date version of the code or whatever you want to hold in Git. You also get all the history on all the different versions of the set files, different branches, past versions, and so forth. If you want to take an older version, you can just do that. Repository is defined by the directory named .git in the root directory of the repository. Usually it's hidden because of the dot prefix the directory has, but you can always go and open it and see it. In that folder, there's all the information that Git repository needs, including like what branch you are currently on, different states, what changes are staged and unstaged, and so forth. Some configuration based on the current repository and so forth. Most of the configuration is not stored in the repository, but some parts are stored in the user folder or somewhere like that. But yeah, when I talk about repository, it's all of the files and so forth. It's really hard to explain what a repository is, but it's really easy to just say a repository. Yeah. And yeah, I mentioned GitHub, GitLab, Bitbucket, so forth. I'll talk about GitHub, but anything that I say applies to all of the other places as well. So if I say GitHub, it probably applies to GitLab and Bitbucket and others as well. So these are just places that host your Git repository. You don't these are not required by the Git system itself. It's basically you need them if you want to host them over the internet, but they are not a basic requirement of Git itself. They work as the remote of the repository, which is actually a word that I will be using at the end. So when I talk about remote, it's the hosted repository that you have on your GitHub or whatever. Sometimes there's some neat additional features on those hosting places, like there might be a system for pull requests or code reviews or cloud-based code editors. I just realized I don't have a separate slide about pull requests or code reviews, but I'll explain them at a later slide if I remember to. If not, then ask if you don't know what those are. And yeah, then I had a slide about all the commands that you might use, but they took so much time that I had to cut them out. So I just have a small sample of basic operations of Git, how it can be used. Actually, this is quite an ordinary case on how Git would be used. So those lines mean there's two different branches in this picture. At first, there's the develop basic master branch, and then with git branch b1 and git checkout b1, you create a branch and then change to that branch. So in your local computer, you are now on branch b1. Those green dots are actually commits. So when you make changes to your Git repo, you make a commit which includes changes, like usually changes to your source code, like different kinds of features or bug fixes or anything like that. So green dot is a commit or change. You can make them by making changes, then adding them to the Git system, and then making a commit by git commit. And yeah, so around the halfway, when there's some commits made to both development branch and then the B1, we want to take the changes from develop to the branch B1, making while we're on the B1 branch, we take the changes by merging the develop branch into the B1 by commands like git merge develop. That's usually the way it's done. And when we are done developing something, whatever we want to, on the branch B1, then we want to usually merge the branch B1 back to the develop main branch. So from a local command line, you would go git checkout develop to go to the develop branch, marking it as active, and then merging v1 into it, and of course then pushing the changes to remote by git push or something like that. Yeah, I hope that was at least somewhat clear on a clear, yeah. Yeah, anyway, then some common problems that you might bump into when using Git or doing stuff with Git. Of course, probably the most common one is a merge conflict, which happens when you're merging a branch to another, and then in both branches, they have made some changes to a same file, which are quite similar at the same spots or something like that. And usually Git understands on what to do in those kinds of cases, but when you have both edited a same line of code, it usually means that Git doesn't understand what to do with that information. There's no crazy artificial intelligence to figure that one out or anything like that. It's quite smart, but not that smart. So what happens is a merge conflict. And when that happens, and you go and open the file that the merge conflict has happened in, there will be lines of equal signs and larger or smaller than symbols. You shouldn't be scared of it. It happens all the time, but you just have to know what it means. So when that happens, there's the two different versions of the code that Git doesn't understand what to do with. And so you just have to check what's the conflicting changes and fix them as best as you can. Usually there's quite a simple way that maybe they just need to be on their own lines, or maybe there's something has been written in a different way, like a variable has been named differently or something like that. Just look at what it is and fix them as best as you can. Usually it's quite easy. But sometimes it's a bit more complex, like there's way different blocks of code and you don't know what to do with that. Then you just consult with the other developer or the other person who made the conflicting change. You can usually find that from the Git log. Then just look at the problem together and combine your changes accordingly so that you can get it working. Yeah, all in all, merge conflicts are quite common. You don't have to be scared of them. You haven't done anything wrong when that happens, but just keep calm and just fix the problem. Yeah. Oftentimes you can do some changes to the code and you don't want to put them anywhere. You have just been testing out something and you don't want to keep them. There's this handy command that you can use. Just git checkout -- with 2 dashes and then the files that you want to throw away. If you did a commit.
No exam this week.
Okay, I am now in the webinar. Do you want me to project it?
Did you hear me?
Yep.
Okay.
I muted him. That was some participant.
Yeah. Okay. Yeah. Okay. Wasn't sure if that was a question, but yeah, no. So anyway, then you might commit something by accident. If you haven't pushed it anywhere yet, it's easy. You can just git reset. There's this a bit weird notation. With this head in capital letters, tilde and n, you can refer to amount of commits that you want to undo. So if it's just one, then it would be head -1. This keeps the changes in your local environment, but if you just want to throw them away, use --hard if you want to discard them. But this makes them go away. You can't get them back. So be careful when using that. Yeah, and lastly, if you did commit and then pushed, and you really didn't want to push those changes, there's always git revert. You can use the commit ID. You can use the same notation as the previous one, or just head and the small hat symbol. I don't know what's that called, but to refer to the last commit. Of course, those work with git reset as well. And yeah, something to be very careful about is rewriting your Git history. With commands like git rebase, you can modify order or contents of past commits, like commits that have been pushed to the remote or other people's computers as well. You can do that, but you really should be careful with it. There's some reasons to do it. Like some people just want to keep their commit history really neat, so that there won't be many small commits, but instead they just like that there's one big commit. Some of our workflows rely heavily on that kind of stuff. I was part of one project that used this kind of workflow a lot, meaning anytime you wanted to merge anything to the main branch, we squashed all the commits that we had made into one large package. That's not the way that I like to do things anymore, and I really don't think that anybody should do this, but some people do and they like it. And of course, you should be really careful when doing anything that rewrites history, because if you do that and then you push the changes, the other people who have worked on the same things, they might end up with a messed up Git state. Might, probably, maybe not, but it might be really confusing at the very least. Sometimes you might even lose some stuff. It's happened to me at least. And yeah, it's a good idea to never do these things on branches where other people are working currently. If it's a branch that only you are working on, even better if it's only on your local machine and it hasn't been pushed to the remote, GitHub. But still, it's really hazard if you do these things on branches where other people are on right now. And if you do anyway, make sure to tell the other people on the branch what you have done and why, because then they can at least try to adjust to it. Yeah, usually when you push changes like that, like you have maybe altered past commits message, you have to use this force flag with the git push. So that's a good intention that you are doing something that could be dangerous. Usually, a better option is to use force with leash, because it makes sure that you haven't done anything harmful. Like if it hasn't altered the, for example, code itself. Maybe you only wanted to fix a typo in a commit message, which really doesn't harm anything. It's not just the most clean thing. Or actually, yeah, if you just want to make a commit message cleaner, then you can use force with leash, which makes sure that you haven't done anything dangerous. It can still be a bit weird looking at the other people's end, but at least you can be sure that it's probably not that dangerous. And a good golden rule is to never force push to main branch. Of course, if you're only on your own small Git branch that you're testing things out, then go ahead to do anything that you want. But if you're doing anything else than that, even if you're developing your own program, you really shouldn't force push anything to main branch at the very least. But yeah, I think that's all that I have about Git basics or Git in general. So now we should go on how me and my project use Git in our project, which is called Harja, a broom in English. It's shortly about the project. It's actually open. It's actually open source project hosted in GitHub. If you just search that Harja from GitHub, you might be able to see it and see the code I have written. Don't look at it too carefully. But yeah, it's a quite large project. We have around 10 people in it. Not everybody is a coder, but most of the people who are in it actually write code as well. It's a larger project than usual, so we have to take extra care when using Git, and if we do something careless or hazard like force pushing or rebasing and stuff, we might just mess up a lot of people's days if we do that carefully without any care. We have a continuous deployment based on the main branch, meaning whenever we push anything to the develop, we start building the next production version of our code, meaning, well, it's not actually fully continuous. It's every morning basically, but we have to always be careful about what we put on the main branch, which is named develop, which you can see from GitHub if you look at the project. And of course, we wanted to keep the branching model as simple as possible because it is a large project. It's, as I said, I don't know how many coders we actually have, 7 or 8 or something like that. And the project has been on development for quite many years now. So we just want to keep things as simple as we can. So usually, this is not all the time, but usually, whenever we start doing a single task, we make our own separate branch. Like you remember from the previous slides, you can create a new branch. It's developing their own branch. Usually the branches are named quite clearly after the Jira ticket. You might be familiar with Kanban or something like that. So that's just like one small task or ticket. And then a short explanation, something like that, where there is the ticket name and number, and then a short explanation. So the development of the said task is done in the branch, and if there has been some changes to the develop branch, we merge them to the feature branch. Usually the branch lives for 1 to 3 days, maybe. So there might be some changes to develop. Usually there are. And of course, at the latest, right before we merge the development branch back to the develop. And then after we have developed the feature in the set branch, usually we write automated tests, etc., etc. We make a pull request. Oh yeah, this is the part that I was supposed to tell more about pull requests. So basically, there's a button in GitHub to make a pull request. After when we make that, we can ask another developer to confirm that this change is good and okay. They make a code review. They look at the code that we have written and approve it and so forth. Usually there will be some comments like if a variable should be named differently or something should be done differently, or maybe they found a bug that we missed or something like that. Yeah. So when the pull request is approved and the automated tests that are actually run in the somewhere else in the cloud, they have passed, then we just merge the branch back to the develop branch and life goes on. We take a next task and continue. Except that's the most simple and most common case, but that's not always so, because sometimes we have these large features that might take weeks or even months to get through. So yeah, actually I'm a bit behind the schedule, so I have to pick up the pace a bit. Sorry about that. But yeah, we make a separate feature branch, which is a bit different from the branch that I mentioned in the last slide. It's a feature branch, meaning when we split a big task into smaller parts, we make a single branch, and then from that single feature branch, there's like develop first, then there's the feature branch, and then after that we split it into even smaller parts and branches as well. Usually one per split task, if we are able to split the task that easily. Sometimes we just make 2 or 3 people who are working on the larger feature. Sometimes we can just push our changes to the feature branch, but usually we make branches as well. Then when we have made those smaller, like third level of branches, we merge them back to the feature branch with or without a code review. It depends on the complexity of the code and the mood and position of the moon or something like that. And then if we have the changes to develop in the meantime, they are merged to the feature branch every now and then. We try to keep it as up to date as we can, but yeah. And yeah, there's a small like this illustration of it, I guess. So there's this develop branch. At the first dotted line, there's the feature branch is made. At the second dotted line, there has been a change in develop branch. And also there have been made a few branches from the feature branch as well. At the third dotted line, we merge develop into the feature branch. And at the fourth dotted line, we haven't actually, in this case, we might have not merged the feature branch onto the smaller branches. And when we merge the small feature into the feature branch, we might end up with a merge conflict, which we'll fix in a way or another. And of course, after that, we make a pull request and merge it back to the develop. This is like one sample case that might happen. Usually they are a bit more long-lived than that, but some sort of a sample as well. And that's basically about 90% of the cases that we use Git in our project, trying to keep it as simple as we can. A few things that I didn't mention is that we try to commit as much as we can and as small commits as we can with good descriptions. But yeah, I think we should move on to the last part now, which is the most important part for you guys, which is the GitHub portfolio. So, when we are preparing for an interview with a candidate, whether it be for like this, we have the Dev Academy and so forth, we usually take a peek at the candidate's GitHub page or GitLab or GitHub Bitbucket or whatever. And if we see that it's basically empty, there's nothing in it, there's just the profile, it really doesn't tell anything. It doesn't even say that the candidate is not active. It just says that they haven't done anything on the GitHub page. It's usually not a great sign, but doesn't really tell us anything. But instead, if there is a good GitHub page, it tells us a lot about what the candidate is interested in, what skills they have, how active they are, how passionate they are about their interests, and so forth. So, how do you make a good portfolio for GitHub? So, just basically don't have an empty GitHub page. If you can do any small, no matter how simple it is, any projects are better than none. So try to put everything you can on your GitHub. It doesn't really matter how small or easy the thing is. Just it's not a bad idea to put everything to your own GitHub page. All projects or studies or anything that you can. Maybe if you've done a group project that somebody else has hosted on their own GitHub, you can do a fork of it to your own profile. So that at least in GitHub, there's when you go see a project, you can just press fork. That way we can see that you probably had something to do with it, and then we can go look at the project and see what you have done to it. Commit often with good messages. So before I mentioned the one model where they squash all the commits together into a big complete ones. It's not usually the best one for our interests, at least. When you have small, good commits, did my slides just break? I don't know. I hope not. But so there are many ways you can make a good commit message. One such way that I try to follow at least is to follow this kind of format. So when this commit is applied, it will, and then write your commit message over there. For example, the commit message would be to align the cat picture correctly. So you could say, when this commit is applied, it will align the cat picture correctly. You don't have to do it that way. It's one way to do it. And if you follow that kind of a format, then the commit messages will be consistent, which is a good thing. It will be a bit easier to read them. And try to avoid these kinds of, actually it should say comments, not commits, commit comments. They should tell something. They shouldn't be just fixing a bug, add feature. They don't tell anything. They don't tell what you have done. try to avoid those. I mean, they are better than no explanation, but you can usually add a bit something more interesting to that. Of course, you can actually write a multi-line comment, of course, so the title can be quite simple, and then on the following lines, you can give a more in-depth explanation if you need to. And of course, don't worry about writing perfect code, especially when you're learning new stuff. When you're learning new stuff, actually writing just something at the start can tell us quite a lot about your learning process. Bonus points if you have a clean commit history, so that we can actually learn and see how your skills progress. If we have time to look at the commit history a bit more in depth. And of course, when you're just working alone in a linear fashion, like you just do one task after another, which is usually at least how I do my own projects, you really don't need to use branches. They just might cause unwanted clutter. Of course, if you want to practice using branches or show that you can, then go ahead. Don't be afraid to use them either. But you don't always need to use them if there's no need for it. But usually just when you're working alone, when you're working with just even with one other person, then it might be a good idea. Yeah, so well, every project, even the ones that are small or unfinished, I know I have a lot of unfinished projects on my GitHub. It would be a good idea to try to make one finalized project. Just no matter what it is, it doesn't have to be that complicated or fancy, or it doesn't have to serve any other purpose than to showcase your skills or learning. Things that should be in the project. It should be easy to review, meaning when a recruiter is looking at it, it should be easy to digest. It should be easy to run on either a local machine or a hosted machine somewhere. A readme.md file is important. I will tell you more about it in the next slide. Clean commit history, as I said already, is important. And of course, the project should showcase your learning ability, technical skills, and/or passion in some way. That's just a really big bonus if you have something like that in your GitHub. So the readme.md, it's a file in the root folder of your repository. It's usually the first thing that you see when you are opening a repository on GitHub. If you open any repo on GitHub, it's the first thing that you see. Well, under the source code or the files, then there's the source readme file. And at least these things should be on the readme. Why the project was created. For example, this project is supposed to teach me React or something like that. What does it do? Usually a project does something, so you should tell what it does in the readme. Technologies used are important. You can usually see them otherwise, but it's good to have on the readme as well. So it's clear over there. How to run it, it's really important. This when I have looked at some sample repositories or sample like this, these projects that are meant to work as a demo or a showcase, it's really important to show how to run the project. We usually don't just want to look at the code, we want to run it and see for ourselves how it works. If it's a web application or so, it should be runnable in some way. And a license is a good thing to have as well. I'm not gonna talk about those too much, but license is a good idea as well. Continuing on the Readme. So yeah, summary, motivation, summary, tech stack, good things to have. As I said, for example, studying, if you have done only a project to study something, it's good to mention it so that, because it might change the way that we look at it. Versions are important, especially when writing instructions on how to run the project. Java 11 is different from with Java 8 and so forth. And yeah, the guide to running the applications is, it can be hard, at least in my experience. I'm not great at writing those things, so they are not so obvious always. Mention all the dependencies that you need to run. If you have a Java project, mention that it needs a Java runtime environment or a JDK or anything like that. If you need something, mention it. Yeah, or a node application for if you have something done with JavaScript. Mention the minimum version you need, or at least the version that you have used while developing it. If you only made it on Windows, mention it because it might not work on Linux or Mac machines as well. Usually, at least we have usually only Mac or Linux computers. Clear steps to run it from the dependency installation to seeing what's on the screen. All the single steps, like if you need to install node.js, you can just link the instructions to node.js or something like that. They don't have to be too complicated, but just have some clear steps on how to do it. Or Docker. I'm not sure if you have learned about Docker too much, but if you haven't, it's a really great thing to have on your sample projects. When you have containerized your applications, it can be run on every system, and it's usually so easy to do it as well. So if you have time or interest, just look into Docker. If I'm reviewing your application at one point or another, if you have a Docker image ready to go, I will thank you. Or host it somewhere else, like Heroku, Netlify, or even GitHub pages. Hosting, if you have used some free hosting service, it also tells that you can do that, and they are not always the most easy things to do, but a great alternative to having the person testing it run it on their own machine. And yeah, I think that's about all. I have just a few slides of motivational slides about Solita and our customers. You can look at those for now.
Maybe I can start the commenting and questioning section by saying that Jere brought out like tens of excellent points on how you can use Git and what kinds of features and tools it contains. And what's actually like common for almost all of those tips is that they're not about how you use the tool by yourself. They are about how you cooperate with your team. So that's a really big issue in the industry when you come to work at the industry, start working with real software development, is that you need to like learn these skills, that how you can share the code, work on a same code base with other developers on your team. So that's an excellent point in this presentation.
Yeah, I have a question if no one else is asking anything. So you presented now one of these Git workflows here in your presentation, and it was for this Harja project, I guess. So is this like some kind of standard workflow that you're using in all of your projects, or do you have some different kind of workflows based on the project?
Did I break my presentation? Can you see anything anymore?
Yeah, you're going back.
Yeah.
Okay, it works. Okay, I opened the chat, so I thought I broke it. Where was it? Did I already show it? Is it here? Is it this one?
Yeah.
Of course, as I said, there's no only one way to do things, but this is like quite the basic one. This is a really common one, but not the only one, of course. So some people might have one branch like on top of develop, or like before the develop branch. They might have, I think this one, this specific flow is worth mentioning, that they might have a develop branch where they only push certain releases. So instead of continuous development or continuous deployment, they only want to deploy certain versions. So they might have one single branch that their develop is based on, and then they only push changes from develop to there every now and then. And maybe they don't even take all the changes. They might only take certain points, or they might use DAGs, which I didn't mention at all because I don't really understand them either.
Yeah, so my question was more about that. Is this like the standard way of working with Git at Solita, or does it vary by project? Is it different per project?
I think this is quite the basic setup. So our projects are autonomous in that sense that we can all decide that how do we do stuff. But this is pretty much the basic setup, that we have a sort of a main baseline, and then we use the branches for developing new features and so on. Because using the branches, that sort of stabilizes the main branch. So there's not like dozen of developers pushing their unfinished code in the main branch all the time, but this is like keeping the main branch in sort of a stable state. And also this is a quite good enabler for the code review processes. So when we have the features, bug fixes in branches, they will stay there until some other developer has done the code review and decided to merge those features into the main branch. So this is quite common. I know that there are some projects in Solid that are using different kind of approaches. I think there might be even some blog postings about master-based development where the so-called feature branches are not being used.
Yeah, I have another question. There is something in the chat. I can read it to you, Jere.
Yeah, actually, I can see the chat now.
Okay, you can see it. All right, so you can answer it or read it and answer it directly.
Yeah, so the question is about GitHub usernames. That's not actually any silly question at all. But yeah, it's about, do you pay attention to the GitHub username? I assume when if I would be looking at a candidate for an application. So, for example, should it be first name, last name, or should it be master coded 420? I don't really care about that too much. I mean, of course, if it's something inappropriate, I will take a notice of it. If it's something funny like master coded 420, I don't mind. I prefer, for myself at least, to keep it professional and simple. I only have my my name basically on there, so a name looks a bit clear and professional. But if there's a tag that is not inappropriate, I don't mind either. But having your name as your username is, well, you can't go wrong with that at least.
Hello, I have a question for Jere.
Yeah, go ahead.
Thank you for a good presentation. And I would like to ask, just for curiosity, do you have a favorite Git command reference if you don't remember every command? So,
yeah, I actually do. My favorite actually is I personally use Git from my command line, so I just use the help from it. Basically, if I need to refresh myself on how to use a single command, I just write git the command and -- help. That usually tells me all that I need. But of course, that's not the best way. That doesn't really help if you don't remember the command that you use. So in those cases, I just try to Google as best as I can. So answer to your question would be no, I don't have a favorite cheat sheet of a kind. There are plenty of them online, and from what I've seen and used them, they are all pretty good. I hope that answered your question at least to some extent. I said yes and no.
yeah, you answered. Thank you.
Yeah, good.
You mentioned that you have a code review before a feature is merged to a develop branch or release branch, or however it is called. So can you describe how the code review is usually organized in your project?
Yeah, so we've tried a few ways. The most common is that since we usually split our tasks in quite small parts, they're usually quite simple. So we have the branches and so forth. When the branch is finished, the developer that made the thing thinks that it's done. They just make a pull request in GitHub, and then they ask for somebody else to check the code. Usually it's just the other person just checks the code, maybe tests it on their own environment, and if there's nothing weird or bad about the code, they just say looks good and puts a thumbs up, and that's it. If there are some bugs or things that if they don't understand something, they can just add a command to GitHub and so forth, then they are fixed and resolved and so forth. That's the most simplest and common one. There's no specific system on how to do it. They just look at the code and tell if there's something wrong about it or if it's just good enough. We have tried some more complex ones, like this kind of now the term evades me, but these kinds of systems where we take the developer who made the changes and they will present it over, these days over just some screen sharing system, and go through the changes and motivation and reasoning behind it together and look at the code, usually line by line if it's not too big. And look at the code together.
Yeah, that was something that I also thought of mentioning, that sometimes the changes are so big that necessarily the one who's doing the review doesn't like see the whole big picture, and then it helps to call the friend that asked that could you please explain me that what have you done, why, what are the reasons behind your solutions, and then it's much easier to walk through the code line by line, function by function, to see whether the code actually does what it's meant to do.
Okay, how about what is your approach to testing? Let's say that you have this kind of new feature has been completed by a developer, and then there is a code review being arranged. So do you have a policy that the developer who implements the feature, they should also implement unit tests or some kind of other test, code-based tests, or is it some kind of manual testing, or what is the policy there in your projects?
Yeah, good question. There's no, as before, the projects themselves can also always decide for themselves. So Solita never says that you have to do this or that. But in our project in Harja, we have this loose policy that we should always have tests depending on the developed feature, because we have these separate parts, like front end has different tests than the back end and so forth. But in our project, we have a policy that there should be at least some kinds of automated tests with all the pull requests or the features that we have developed. There's not, and we are a bit lazy about that, but at least usually there is, and we do have the policy that we should have some tests. And of course, usually manual testing is requested separately or depending on the code or the complexity of the task.
And yeah, we're also using those automated tests by code for the actual development. So for example, when I'm doing some API changes for APIs which the applications are using to discuss with other applications, then it's quite easy actually to replicate or build the scenarios with automated tests. So there's this method called test-driven development, and many cases we actually do the tests before the actual implementation.
Yeah, the test-driven development is something that we sometimes do as well.
Yeah. Test-driven development can be a bit tricky to get started with, but once you get hang of it, then in my opinion, it produces quite good quality. And also enables this kind of automated test running with continuous integration systems or deployment, which is a big bonus in long lifetime projects.
Yeah, there are a few questions in the chat still. I'm not sure if I understand the first one correctly. How the question is how the code is split into those slices of features to code the way that they don't conflict too much. I'm not sure if I understand correctly, but we don't care at all about the upcoming conflicts. Meaning, if we have two separate tasks that touch the same area of code, I mean, for example, if we have two tasks that affect the same file, we don't really care at all. We just do them and then resolve the merge conflicts when they come, if they come at all. So if there will be merge conflicts, then there will be. We usually don't coordinate because it's not something that, I would say we are not afraid of merge conflicts. When the merge conflict comes, if it's complicated, then the two people who made the conflicting changes, they will sit together and work it out on how to combine those changes. We haven't had any problems with those things. So if we run into a complex merge conflict, we coordinate then if we need to. Usually we don't need to. Basically, it hasn't been a problem for us so far.
Yeah, the question is actually if you have an idea on how to solve a feature, then do you have to worry about somebody else having something related to that and talk that I'm going to use this kind of technique, so you should consider this in doing your part of the work? Or if it is an opposite situation, like you have to consider what is going to be other solutions. So when you get your idea of solving some feature, you kind of work the way that it fits with others' code.
Okay, yeah, I think I understand, but that's not something that we usually need to do. We always have these daily meetings, of course, which usually are in every single project. If we do run into that kind of an issue that two people are doing almost the same thing, we might think if we should do it differently. Like if two people are doing the same thing, then there's something has gone wrong, and then we should work it out in such a way that the two people don't do the same, or at least almost the same thing. So that kind of coordination will happen, but there's some things about that thing that we haven't run into any of those kinds of issues.
Yeah, I don't know if there's any like detailed technical patterns for that kind of work. We usually talk quite a lot with each other, as Jere mentioned. All our projects are usually having these daily meetings in the mornings, and there we share the statuses and plans on how we are going to proceed. And it's quite easy to share ideas with the other developer who's going to start working on the similar feature. So talking with each other helps a lot, avoiding these problems and going into wrong directions.
Yeah, and when in doubt, we would just look at the code together, look at the differences, for example, with screen sharing or whatever, just to look at if somebody doubts that there will be some issues, then we just would just look at them side by side and figure out if there will be a problem. And if there will be such like a problem that requires figuring out on what to do next, then we'll just take 15 minutes to do that, or how long that it will last. Yeah, I hope that answered your question at least somehow. Yeah, I think quite a big part is that in these kinds of big projects that we have, or at least the one that I have done, we don't have those same kind of problems. That's because that's a kind of problem that you have when doing like this study projects. That's something that you might run into a bit more often in those kinds of things, but we don't run into those kinds of problems that often in our projects, maybe because of the size mostly. But yeah, also there was another question of if I could share some of my first projects related to web development. Unfortunately, I really can't, because I really actually don't have my own hobby projects that much. I learned mostly while working, which is probably not the most ideal way to learn things, but it's the way that I learned. web development, just on the job. I do have